Hi. So today we have a Samsung S10 that was mailed to us. This phone is in here for data recovery. According to the intake form or the notes from the customer, the phone was in use and then it froze and then it started to boot loop. But now, while it's in the shop, it shows absolutely no signs of life. Uh, Let us try and recover this customer's data. He wants all of his pictures, messages, and the Samsung notes recovered. Now, let me show you what the phone does. So while the phone is plugged into the charger, it draws 5 volts and 120 milliamps. And then if I press the power button, there is no change and it shows no signs of life. And even if I flip the cord over and plug it in, it is still the same. Let's disassemble this phone and we'll take a quick look. And it's the same. No signs of life. Okay, so I have disassembled the phone, and according to the notes left on the invoice by the customer, or according to the notes on the work order, the customer took it to another repair shop, but they didn't do any work. But after I took the phone apart, I noticed that this shield was cut away, but it looks terrible. It almost looks like it was cut open by a can opener. But let's connect it to the DC power supply and let's see what kind of current draw we get. Okay, there's no current draw before prompt to boot. If I press and hold the power button, the device draws 163 milliamps and just sits there. Strange. Let's get the board out of the housing and we'll take a closer look. Next step is we'll get the board out of the housing and we'll check it with a thermal camera to see if we get a heat signature. Because at 163 milliamps, there should be some heat signature on the board. That would give us an indication of what might be wrong with it. Okay, so this is the board. I've taken the entire board out of the housing, and it looks like some soldering was attempted on the back as well. It looks like somebody tried to change the Max IC, or at least worked around it, because part of the shield that covers the Max IC and the UFS has been cut away as well. Let's take a look at it under the microscope. Okay. So it looks like the Max IC has indeed been replaced. There's a bit of flux on the back, but on the whole, it doesn't look horrible. So just based on the look of the shield and the heatsink on the back, it does not look like any kind of soldering was attempted on the UFS or the CPU. So it's definitely a good sign, but I think our next diagnosis steps don't change. Let us connect it to the thermal camera and let's see what kind of current draw we get. Let's connect it to the thermal camera and let's see what kind of heat signature we get. And we'll take this shield off because we don't need it right now. And it'll also help us check if the UFS or the CPU is coming on. Okay, so I have the phone connected to the DC power supply, and we're going to prompt the motherboard to boot with some tweezers, and let's see what kind of current draw we get. So it still draws 160 milliamps. And it looks like the CPU is starting to turn on. And if we remove the UFS shield, I'm sure we'll see a heat signature on the UFS as well. And then if we look on the back side of the board, there is no obvious hot spots. So based on the symptoms so far, it does look like this thing has a disconnected CPU. Let's take the shield off of the UFS and the CPU, and we'll take a closer look at it with the thermal camera once again. Now this cutting of the shield is okay. It is not shorting out to any of the components underneath it. So the problem is definitely with the CPU or the UFS. Now sometimes on these guys the UFS can die. That would also show similar symptoms, so I'm hoping that that is not the case. Let's take the shields off of the UFS and the CPU, and we'll take a closer look. I'm just gonna tin the pads of the shield with low melt and take it off that way. I could cut it off too, but the pads are pretty easily accessible on this board, so I'll just have it's just safer to tin it with low melt and remove it that way, and it won't take that much longer to do it this way than to cut the shield off. So what I'm going to do is I'm going to pin the pads for the shield with some low melt solder. That'll help the shield come off at a much lower temperature. Let's do the same on this side, and then we'll come in with a little bit of hot air, and that should help us take the shield off nice and easy. So to remove the shield, I'm just going to use 265 Celsius at 60 airflow. Excellent. Alright, now let's do the same thing with the CPU shield as well. Let me just adjust the board. Okay, Come in with some hot air once again. Haven't been able to tin the pads in the top of the shield very well. You just come in from a better angle and make sure those pads are low melted as well. Okay, now it should be good to come off. Excellent. Okay. Let's try and lift it up from this side. Awesome. It's coming up. Now we can just wiggle this off. Perfect. Okay, so the shields are off. Let's clean up some of this excess solder on the side. Okay, excellent. We'll let it cool down and then we'll check it with a thermal camera once again. Alright, now that the board has cooled down, let's prompt it to boot once more and we'll see if we have any abnormal heat signatures. And because we've just put heat on the UFS and the CPU, there's a chance it might boot as well. And yeah, looking at the current draw, it looks like this device is powering on right now. So that pretty much confirms that we're dealing with a disconnected CPU. So let's just reball the CPU and that should fix this device. And it should allow us to recover the customer's data. Let me just switch on the other camera and then I can show that this device is booting. So after desoldering the shields, while the board still has some warmth to it, if I prompt this board to boot, okay, there we go. Of course, when I try to show it on the other camera, now it's back to the same 170 milliamp draw. Of course, but the fact that it was trying to boot while the board was still warm is a good sign. We should be able to reball the CPU and recover this customer's information. So I'm just going to clear the solder from these solder pads on the edge here, just because it'll allow me to insert the desoldering tool at the perfect height. Now we'll start off by clearing some of the underfill around the UFS so that it does not take these components off with it. Actually, that just looks like flux. Okay, so let's just preheat the board, and then we can proceed with the removal. Okay, I'm going to use 380 Celsius at 100 airflow to remove it. Excellent. Let us quickly correct this capacitor that got budged. Perfect. Now, before we do anything, let's just check the UFS health and make sure that it is good. So there are two reasons why these phones stop booting after some time. It can either happen because the UFS is starting to fail, or it can also happen because there are cold solder joints between the CPU and the board. Now, so in order to make sure that we don't go wasting time, the first step is to desolder the UFS and then check its health. If the UFS health is good, then we can proceed with the CPU reball. I'm going to start by first clearing the underfill from underneath the UFS. I've thinned the solder pads on the UFS just to make sure they melt a little bit faster. And then I'm going to use my underfill removal tool to gently just scrape off all of this underfill. It is very important that you're careful with how much heat you apply to the UFS because it can die super duper easily. And that's why I tried to take the UFS off as soon as the solder pads underneath it had melted. And that's why you can see most of the solder pads on the UFS are gray and oxidized. Going to clean the remaining flux and then we'll reball the chip and then we'll test it. I'm going to try and thin these pads again with a little bit of leaded solder, and then we'll proceed with the reball. Once we've reballed the chip, then we'll test it in the programmer. Okay, let's see. I might be able to clean the flux and also tin those solder pads using my desoldering braid. Basically what I'm doing here is I'm using the braid to scratch the pads that are oxidized, and because the braid is also saturated with solder, as soon as the oxidation is scratched off, they will accept the fresh solder from the braid. This technique works pretty good, pretty well. Now you have to be very careful when doing this, because if you apply too much force using your iron, you will easily scratch the surface of the chip, and that's something we want to avoid at all costs. I mean, a few scratches are not going to kill the chip, but it doesn't look good, and it's always best to try and be precise when doing this kind of work. Now let's just tin those solder pads once more, and then we'll clean the chip and reball it. Now it should be ready to accept fresh solder. Excellent. No scratches on the chip. It looks good. Let us reball it. Don't have a lot of paste left on my tool, but I think what we have on the tool right now should suffice. I have to move our stencil a little bit so it lines up. Try reflowing it once again. Let's try moving it once more. Perfect. Put a bit of flux on there. So I think what happened was, as I was putting the paste on the chip, it fudged a little bit, and that caused the solder pads underneath the stencil to move out of alignment. Thankfully it wasn't too far off, and just reflowing it has allowed all the solder balls to attach nicely. These guys on the right don't seem to have attached, which is strange. And of course, that got moved way too much. We're gonna have to redo this. Aggravating, very aggravating. Oh man, it is annoying when this happens. Okay, let's do this. All right, so we have the chip lined up underneath the stencil. Let us reball it. We've got barely enough paste on our tool. It should suffice. And hopefully this time it did not budge. All right, let us reflow it. Man, it almost looks like I've never done this before. Keep. Okay. Hopefully it's gonna work this time. Perfect, finally. All right. Finally have a good reball. Let us reflow them, and then we'll clean the chip and we'll test it. Excellent. Okay, the chip reball is complete. Let me clean the chip with a cleaner cloth. All right, chip is clean. I'm gonna clean the stencil quickly while I'm here. The stencil is clean as well. Perfect. Okay, let me grab the JC programmer and then we'll test the UFS. Okay, so my UFS programmer is ready. The first step is we'll put the UFS in the programmer. And if the UFS health is good, or if it is able to read the UFS, that light will go green, and it does. Perfect. Now let us check the actual software and we'll make sure that the chip can read. Excellent. It is able to read the chip, and it says its health is 90%, which is excellent. Now let's back it up and we'll see what the read speed is like. Perfect. The read speed is good. It's at 160 Mbps. Now we can proceed with the CPU reball. Perfect. It was able to back up the UFS chip fully. That means it's able to read it fully. Now, of course, because the backups are encrypted, we can't do much with the backup itself. But the fact that it is able to read the chip and make a full backup indicates that the chip is good. Okay, we're going to do the same thing. I'm going to preheat the board first, and then we'll remove the CPU, and then we'll remove the RAM, and then the CPU. Okay, we're going to put a bit of flux around the CPU. It's going to help the heat transfer better, and it will help us take it off much more safely. I'm going to use 390 Celsius at 100 airflow. We're going to start by removing the RAM. Excellent. The RAM is off. Set that aside. Now let's take the CPU off. Excellent. The CPU is off. Perfect. And no cold pads. All right, let's begin by cleaning the board and preparing it. I'm going to tin the pads with some low melt solder, and then we'll braid it. All the underfill came off with the UFS, so that part was decent. I'm not going to have to worry too much about cleaning up the UFS area, but there's a fair bit of underfill under the CPU that'll have to be cleaned up and prepped. Piece of braid is pretty well saturated. Excellent. Now let's do the same thing with the solder pads under the CPU as well. We're going to tin all of them with low melt, and then we'll grade it, and then we'll take off the underfill, and we'll grade it again if necessary. Okay, so to grade under the CPU, I'm just going to grab a fresh piece of grade. Now the solder pads that are covered with underfill, they're not going to get graded that easily. So what we're going to do is, once we've cleaned up most of the un-underfilled solder pads and made them nice and flat, we'll come back in with our underfill removal tool and clear out all of the stubborn underfill. Wonderful. There is not a lot of underfill here, which is great. Kind of. Most of the underfill is on the CPU, so that's going to be a bit of a chore. But the Samsung underfill cleans up pretty easily, so I'm not too concerned. Now, because these solder pads in the center have not gotten pinned with low melt, we have to be a little careful in scraping underfill off of them, just because we don't want to pull any pads and just risk prolonging the repair. That cleaned up pretty nicely. Excellent. Okay. I see just 3 NC pads came off. So we got 1, 2, and 3. But otherwise, this is perfect. So the fact that only 3 NC pads came off is actually pretty damn good. Sometimes more come off the board, but in this case, we took that chip off perfectly without any collateral damage. Now let's tin the board again, and then we'll grade it, and then it should be perfect and ready for the chip. Want to make sure all of these oxidized pads are nice and thin, nice and shiny, and ready to accept fresh solder. Now a lot of these pads that have already been graded won't accept solder from the iron as readily, but it's not a big deal. As long as they are nice and shiny and are not oxidized, they will work. When we reball the chip, because each individual solder ball on the chip will make direct contact with the solder pads, as long as they are nice and shiny, they will accept the solder on the chip and the chip will get reballed perfect. If you do have stubborn solder pads on the board, take care not to scrub them too hard, because if you do, you could scratch the PCB mask on the board, and then just, besides it not looking good, if you scratch too much mask off, you will have to repair it before you can put the chip back on. Otherwise, you'll have problems with the reball, where it increases the risk of causing short circuits under the chip. Right, just one side left. All right, board is fully prepared. Let's clean up the old flux and we'll inspect it, and then we'll proceed with cleaning the RAM and the CPU. Okay, got a little bit of underfill left right here at the top. Let's clear that. Excellent. Okay, now all of the underfill has been removed. Let's give it a quick wipe. All right, the board is nice and clean. Fantastic. We'll first start by cleaning up the top of the CPU, and then we'll work on its bottom side. So first, actually, what we're going to do is let's tin the top and bottom of the CPU with a bit of low melt, because if the bottom of the CPU has any extra large solder balls that are hanging out, that will cause a whole lot of problems, or we don't want to accidentally bend the chip as we try to clear the underfill from it. So we're going to turn this chip over. Yeah, see, we've got a couple of big solder balls hanging out in the center of the chip. We have to make sure that all of those solder balls have been removed and the chip is perfectly flat before we start to tin it and clear the underfill from both the top and bottom of the CPU. Do the same thing. Just put a big glob of low melt on the iron and just go ahead and tin everything. Now, because these capacitors on the back of the CPU end up taking a bit more solder than we would like, we'll come in with our braid and clear those pillars, for the lack of a better word. This will help get rid of all of the extra underfill as well. Okay. It looks much better now. Let us flip this chip over and we'll fix its top side first, and then we'll come back and fix the bottom, and then we'll do the same thing with the RAM. Give it a quick wipe, get rid of all of this excess flux. Now let's come in with our hot air. So I have it set to 265 Celsius at 60 airflow. Okay, looks like most of the underfill has been removed. Now let's just pin and braid these pads, and we'll scrub the rest of the underfill away. Beautiful. Top of the CPU has been cleaned. After the scrubbing, it looks fantastic. Okay, now let's work on the bottom side of the CPU. Now I'm going to use 300 Celsius at 60 airflow to clean the bottom, just because if some of these solder pads did not take the low melt solder, it'll be a lot more difficult to clear the underfill. And I don't want to pull any of the CPU pads or damage them during this cleaning process. So just a little bit of extra heat will really help out. You want to do this as gently as possible to avoid scratching the surface of the CPU. Because if you end up scratching it too badly, that could make the device not repairable. And then see, as I was saying it, I ended up scratching it on the edge, but I think that should be fine. Stop talking and I'll focus on the cleanup. All right, the majority of the underfill's been removed. Let's just scrape it or scrub it quickly with our underfill removal foam. Okay, now we've got a bunch of oxidized pads under the CPU. Let us scratch them to quickly get rid of the oxidation, and then we'll pin all the solder pads again, and then it will be ready for the reball.
Hey, Kermit. It's Repairtech calling about that again now. Unfortunately, I'm pretty confident at this point that it is a problem with the laptop's PCH itself. We were able to reconstruct the BIOS, properly wiped, correct versioning and everything all set up and ready, but unfortunately that hasn't made any substantial difference. Putting the, excuse me, manually triggering the power button signal going to the PCH itself doesn't appear to change any of its behaviors. None of its secondary rails are coming on. It's not actually responding to the power button prompt. At this point, we're pretty sure that it's a problem with the PCH itself, and that's not replaceable, unfortunately. Yep, it's pretty much reassembled. I just need to put in a few more screws, and then it's good to pick up. Okay. Yep, that's perfectly fine. Okay. Sure. Yep. I will reach out to him, and then we'll give you a call back if needed. For sure. Bye. rails are all good. All of the three. All of the necessary power rails are present. At least for this phase of the boot cycle. None of the major power rails are on there.
Perfect. Just clean the excess solder from the capacitors and then we can reball the chips. Well, no, we have to then clean the RAM and then we can reball the chips. Beautiful. That looks perfect. We have one solder pad that's oxidized, or two of them. But those can be fixed during the reball anyway. But since it's only two of them, we'll just do it right now. Awesome. Let's clean the back side of the CPU as well, or the top side of the CPU. Excellent. All right, now it is ready for the reball. Now let's take a look at the RAM. Okay, now we're gonna tin it with a bit of leaded solder and it will be ready for reball. Got a couple of oxidized pads on here as well, but they can be cleaned up during the reball itself. Get rid of that. Perfect. Awesome. Gorgeous. RAM is clean. Alright, let me prepare some fresh solder paste and then we'll reball the CPU and RAM. Okay, so I have the fresh solder paste prepared. Let us reball the CPU first and then we'll reball the RAM and then we'll put it back on the board. Fantastic. Just have a couple of balls that didn't attach. Let's see if we can coax them back in place. Perfect. Perfect. Awesome, I think that did it. Let's peel this off and we'll take a look. Fantastic. That is a good reball. All right, let us clean it We'll make sure that the solder bolts are even, but so far it looks really good. Really good. Okay, let's grab our toothbrush. Okay, we have one ball that did not attach. Dang it. I wonder if it is still in the stencil. Probably. We'll take a closer look. Okay, are you in the stencil? Yes, you are. Perfect. Okay. Should just be able to coax that guy back down. Gonna put a bead of flux on there and make sure it is nice and attached, and then we can clean it up. Excellent. Beautiful. That looks really good. Okay, let's make sure that the bolts are even. Well, let's clean up the back side as well, and then we'll check. Okay. And we have a perfect reball. Awesome. Really awesome. Let's clean that. All right. All right. The CPU has been reballed. Let us reball the RAM. Oh, we gotta clean our stencil here. All right, stencil has been cleaned. Let's quickly scratch the oxidized pads. There's only 2 of them. We did a pretty good job preparing the RAM and the CPU. That's why the reball went so smoothly. Don't want to jinx myself and have problems with this, but I think we should be okay. Fantastic. All right, RAM is reballed as well. We'll clean it, we'll test it. We'll clean it, we'll check and make sure we have an even reball, and then we'll put it on the board. And that should work. Okay, let's use the toothbrush. Perfect. That looks excellent. And let us make sure that all the balls are even. And that looks excellent. Okay, it is time to put these chips back on the board. So we'll start with the CPU. We'll put the CPU on, the RAM, and then the UFS. Now when putting the CPU on, you need to make sure that the orientation is correct. So the dot goes on the top right corner from this angle. Now in this case, hopefully, just based on how these capacitors on the board are positioned, it's pretty straightforward to figure out what the correct orientation is. But just in case the board did not have any markings. The best thing to do is to mark the board before you take the chips off. You can use that arrow to line up the chip, and as long as it's close enough, it will pull itself into position once the solder melts. Okay, CPU is on. Let's put some flux on top of the CPU, and then we can put the RAM on. Okay, the RAM is on. And now the UFS. Now I like to use lower temperature to put the UFS on just because it is so thermally sensitive. So I've reduced my hot air to 310 Celsius at 80 airflow, and that should be more than enough. And perfect, the chip is on. All right, we'll let the board cool down and then we'll test it. Moment of truth. Let's take a look at the CPU and RAM and see what it looks like. And that is really good. Everything is lined up perfectly. Chips don't look bent in any way. Excellent. Really excellent. All right, I have high hopes that this is going to work. Okay, I'm gonna clean up my desk while we wait. Okay, so we've just finished reballing the CPU, UFS, and RAM. I have the board in the customer's housing. Let us power it on and let's see if it boots. Fingers crossed. Excellent. We have the Samsung S10 logo. Fantastic. It's past the first stage of boot. Really good sign. Now it's loading the OS. And we have full boot. Excellent. Device accepts the passcode and it is unlocked. Fantastic. The data recovery was a success. The device works and all of the customer stuff has been saved. Brilliant. If you have a device that died out of nowhere, you can mail it in. I accept mail-in repairs from all across Canada and the USA. Link is in the bio. And thanks for watching.